Now I want to move on to the idea of comparing two dependent means. Thus far we've looked at two independent samples, look at the variances and the means and the medians. What happens if the data is actually dependent? How do we go about that process? Well, again, the data types applicable will be interval and ratio. It doesn't make any sense to talk about an average for nominal and ordinal data. Now the first thing you want to do is, number one, determine if the data, the actual data, determine if they are independent or dependent, these two data sets that you're working with. If it's independent, we've already covered that technique. If it's dependent, then what we're going to actually do is subtract one from the other. So I have like a before and after testing scenario, or perhaps before and after take some type of herb to see if increases my strength or something like that. The order that you will subtract these will be extremely important in determining what the null and the alternative hypothesis is. Now, if on the before and after situation, if you're thinking, all right, I'm doing some type of intervention, and it's a before and after testing situation, the second test should be higher than the first. So it would make sense to take the scores from the second, subtract from it the scores from the first, and look at those differences, expecting positive values. So then I could simply test the hypothesis that the mean of the differences is 0 as compared to the mean of the differences is greater than 0. The meaning of the differences is 0, saying these two groups are not different. The mean of the difference is greater than 0 because I took the second test, subtracted from it the first. The mean of the difference is greater than 0 is saying that the second test had larger scores. If I subtracted the other way around, if I took the first exam score, subtracted from it the second, then I would expect the mean of the differences to be less than 0 because the first score should be smaller than the second. I can do it either way. It doesn't really matter. We will come up with the exact same p-value and conclusion. It's just a matter of how you're going to organize it. Now, once you do that, you will actually start the process with the differences as your data set. You have your original data, the second data set, subtract them, you have the differences. It's the differences you'll be working with. So this became a one-sample case. You'd be looking at doing a one-sample t-test or the sign test based on the assumptions and so forth, but you're working with the differences. We really are taking two data sets which are dependent on each other, subtracting the differences, so we're actually reducing those two data sets down to one. Now we have that one data set, we'll complete a univariate hypothesis test with it. So, like I said earlier, the null hypothesis will be that the mean of the differences, so I will subscript it with a D, so I know I'm talking about the differences, is 0, which indicates no difference. Both groups are the same. And the alternative hypothesis will be that the mean of the differences, well, depending on the order I do and what the question is I'm actually dealing with, it'll be greater than, it'll be less than, or not equal to. You'd never write an alternative hypothesis with all three of these. That's like mass confusion. What the heck does that mean? I'm running it here so you get the idea that it will be one of these depending on your scenario, your situation you're working with. Greater than, less than, or not equal to 0. And again, the alternative hypothesis will definitely depend on the order that you actually did your subtraction. Now, let's take a look at a scenario. After completing an exam, the professor was not satisfied with the results. As such, he decided to spend an extra day in review and give everyone a similar exam in hopes of increasing grades. The data below represents the scores both before and after. Do the data suggest the extra day of review actually helped to increase the exam scores? So, these scores across here are your first exam. That's like the before. And here's the scores from the second exam. So if you haven't already, I would pause the presentation, enter that data into your calculator so we can work with it. Again, if you want to follow mine keystroke by keystroke, this is L1. This is L2 for me. So go ahead and pause it, and then we get going again. Okay, I'm going to work with the differences. So let's jump to the calculator real quick. I'm going to go to my editor, stat edit, and here's the before, and here's the after. I will go up to L3. So L3 is highlighted. If you're down here, see where that's highlighted there in the very first cell? If you do what I'm about to do here, the calculator's going to get confused. You need to go to L3. Yet saying I'm going to do this on the entire list. Now I'm going to take the second exam, which is in L2. See here L2 popped up there on the bottom. I will subtract it from L1. This is saying take the second exam score, subtract it from the first exam score. And note this is dependent data in that the alignment here, when you look back at the data, the first exam score listed was 32. The first of the second exam score list was 41. That means the first person listed in my data received a 32 on the first exam and a 41 on the second exam. So this is paired data. Hit enter, and there it is. The calculator just did all my differences for me. Now for all practical purposes, I will now concentrate on L3. I'm no longer interested specifically in L1 and L2. So now we jump back to the computer. And you see I have the differences listed here. So everything I will do now will be based on the differences. I am literally going to ignore the original data. The original data doesn't mean anything to me. All right, so I'm going to set up my null and alternative hypothesis. My null hypothesis will be the mean of the differences is 0. There's no difference between the first and second exam scores. The alternative hypothesis but the mean of the differences is greater than 0 because I took the second score, which I expected to be bigger, subtracted from it the first. Okay, now what about my assumptions? Well, the assumptions that I worked with earlier when I did the univariate case was that the data was normal. X is distributed normal. The population was normal. It's the same thing here, only here I'm working with the differences. So I need the differences to be normal. And how do we make that determination? Well, let's go back to the calculator and do a normal plot. So I go to Program, Norm Plot, run the program. My data is stored in a list. And where's my data? L3. This is the differences. I'm not working with the original data anymore. It's L3. Hit Enter. That's not wonderful, but it's not all that bad. So if we decide that is normal, which I could buy that, that's not too bad. I do a one-sample t-test. If you thought there were issues with it and said it was not normal, then you simply switch and do a sign test. So we jump back to the computer. Of course, I'm going to draw my normal plot, which looks like roughly like this. See, that is, for my students, when I see this, I go, all right, that's close enough to what it really looked like. I know they really did it. You know, like I said, it's not wonderful. I'm a little bit concerned about this and this, but it's not that big of a deal. So I'm going to say they're okay. So I will now go ahead and complete a one sample t-test. If you thought it was not normal, once again, what did we do before? When we worked with the univariate case, we did a sign test. So it's going to be a one sample t or a sign test. So I jump back to my calculator again and go to Stat, Test, T-test. I have data. What's the mean under the null hypothesis? Well, it's not 340. 340 just from the last time I did something in here. It's 0. Where's my data? It's in L3. And my alternative hypothesis is in fact greater than. So I can calculate it or draw. I'm going to select Calculate. There's my p-value. Now, I'm sure this has happened to you more than once. As a standard with my students, I have them go out 4 places for the p-value. And this is like going out, what, 8 or 9, something like that. So if you have that situation and you need to switch it back, press the mode key, which is right next to the second key. Go down the float, scoot over to 4. This is saying go out 4 places, is what it's really saying. Second, quit and get out of there. And I just need to run that t-test again. So Stat, Test, t-test. It has all the information from last time. Calculate. There it is at 4 places. Okay, so I'm going to jump back to the computer here. I'm going to see my p-value. equals 0.1441. Therefore, the decision will be failed to reject, and the conclusion for this data will be that it appears, or there's no evidence to suggest that the intervention, the exudative review, actually helps statistically with the scores. Okay, that's it here for the dependent case, and next we need to take a look at proportions.